Hello everyone. I'm Shreya and I welcome you back in this machine learning tutorial series. In the previous videos, we went through the introduction of, we can say, SVM, that is the support vector machine, and we saw the different use cases and application. After that, in the like previous video, we saw the implement that how we can start with for the implementation of the SVM, and we actually saw that how we can what are the different module that we need to have to import, that is pandas and sklearn, and from there we saw that we try to get the features name and target names, and after that we try to convert it into data frame, and we appended another column, that is target, and we try to find out where the target value is 1, that is from where the target values is 1, top 5 values where the target value is 1, and top 5 values where target value is 2. After that we appended flower name as well, and we applied iris dot target names x, that is wherever the target value will be 0, the flower name will contain the species name that is associated with that. And after that we saw lastly we saw that how we can see the data between 45 to 55 using df function. So after that I tried to to store the values before 50, before 50 as in df0, and between 50 to 100 as df1, and here the last one, that is the last one, that is rightmost side is not included one, it is exclusive. Okay, and for the df2 we have df100, that is that we have the results from after 100, that is we have only 150 sets of data sets that we have in this iris data sets. So now after that I tried to import lib.pip as plt, that is which basically helps in plotting, right? So after that I tried to implement uh, I create a plot to draw the graph for depending on the sepal length and the sepal width. For that I have used first 50 for the sepal length and sepal width, and last that is from 50 to 100 I have used same sepal length and sepal width, and after that I have first provided the color green to the df0, that is the first 50 colors, and 100 for between 150 to 100 I have applied blue color and marker as plus, that is it will be represented as plus, and for the blue color it will be as a full stop. Okay, so as here you can see, as for the target 0, that is wherever df0, that is df0 is containing the columns from the 0 to 50. Okay, that is the species name is setosa's target number is 0. Okay, so target number is what, 0. So now after like we will see that how the sepal width and sepal length for setosa is different from the sepal length for as compared to the sepal length and the sepal width for the and that is versicolor. Okay, so for that we will see that how we can implement that we can see from the graph as well that that as the sepal length increases, sepal width also increases for the setosa, but for versicolor it is not same, it varies, it is not very much linear. So after that I try to draw on the petal length as well for the setosa and versicolor. So on that too we can see we have two classes, as we already know in svm we have two classes, like depending on that we try to draw a hyperplane which basically divides it into the classes. So here we can draw a line as we have discussed in the and PPTs also, that between this we can draw a line. So now I will import model selection, train test split, and after that I will take the test size as 20% and train size as 80%. With that, with the 80% of the data we are training the model, and with the 30 like 20% we are testing the model. Okay, as we have 150 data sets, so the length of the X train is 120 and the length of the test set is 30. So now we will import SVC, that is a support vector classifier, and we will see that how we can fit the model. And so after that I fitted the model, that is model, I have assigned model as the SVC, that is classifier, and model dot fit is exactly SVC. And on the after training the after training the model, we tested it on the test by test, and after that I just predicted the model on some values, and we got an array, it shows an error that SVC was fitted with the features name, so we can't give a random values to it. So it represent array 0, array with index 0. After that I just worked with the classifier as c is equal to 1, that is we have only one classifier, that is we will have two classes. And after that I again fit the model with the train set, and I tested it with the help of a score, that is a score function that we have, and according to that we are getting 96% efficiency. And after that when we give the classifier value as 10, that is we have 10 classification, and again we check, we get 0.96 percentage, and gamma is also same, and for that we are getting 0.96. And when we just passed kernel, that is kernel is equal to linear, that is we already know what is linear kernel. So after applying the kernel linear and is testing the score, we get the most efficient result, that is 100% efficient. So this is all about SVM, and we have successfully implemented the SVM on the Jupyter notebook. And you may have understood that we when we provide kernel as a parameter, especially the linear, which is very much popular, as we have discussed in the PPTs as well. So we get the most efficient output. So that's all in this video. Hope you liked it and enjoyed it. Stay blessed.